Okay, so this is week 8, Thursday. We're going to go over the distributive property for semester 2, math 8. Ooh, it's a little bit blurry, but that's okay. We can still make this work. All right, so for number 1, I like to call it the rainbow method because essentially what you're doing is just multiplying it in. So you should have negative 6a minus 48. Number 2, you're just simply multiplying that in. So 4 plus 36x. Number 3, very similar, negative 30 in plus 42. For number 4, it's a little different because it's going backwards. So the way you should think about this, it's A plus B times C. So essentially, this is going back in reverse. And so it's A times C plus B times C. So when you multiply the 2 in reverse, you have 18m plus 20. For number 5, you're now introduced with a negative, so you multiply the negative 8 into the parenthesis, and the parenthesis is right around the negative 4 and negative 3n, which will give you a 32 plus 24n. And for number 6, you're going to distribute the 8, which gives you negative 8b minus 32. That's good. No, don't grab our food yet. Next, we're going to do number 7. No. We're going to get 5 minus 35n. Don't eat our chicken nuggets. Okay, so for number 8, negative 6x minus 24. All right, let's continue on. Then we're going to go on to number 9. So same thing, I'm going to multiply it in. 15m minus 30. Number 10, this one is kind of a backwards one. So you have a positive 24p minus 28. And then we're going to go on to number 11. So this one's a little bit more direct. So 5b minus 5. Number 12, backwards, 5x plus 45. And that's the first page. That concludes with the first page of distributive property. Now we're going to do is we're going to go over to the back side. These questions are a little bit more complicated, so you definitely want to be careful with your signs. Make sure you know your rules of integer here. All right, so first thing to do, we're going to multiply that negative 4. So positive 32x less 32. That is your answer. And I don't like this pen, so I'm going to change it. Yeah, equals 32x plus 32. Okay. Number 14, distribute the negative 6, negative 42 minus 6x. Number 15, distribute that negative 3, you get a negative 3x plus 15. Number 16, distribute that negative 5, you get a negative 50x minus 5. Number 17, we're again working backwards. So you will have a 5 plus 10v. Number 18, we're going to have a negative 8 plus 40x. Number 19, distribute that negative 7, negative 35k plus 28. Number 20, we're going to get a negative 35a plus 30. Number 21, distribute that 5, you get 5n plus 30. Number 22, you'll get 12r minus 32. Number 23, distribute that 3, and you should get 15 plus 15x. And lastly, number 24 is a little bit tricky because you have a negative 10 right here, but you see the dot right there, which indicates multiplication. So you distribute it going backwards, and that will give you a negative 10 minus 90x. And that concludes your worksheet. Okay, so week 8, Thursday, we're going to continue on. This topic is going to be on multiplying polynomials and factoring for semester 2, math 6. All right, let's start off with number 1. It says, write the expression that represents the area of each rectangle. So the area of a rectangle is length times width. If this is your rectangle, the length is generally the longer side of a rectangle, width is the smaller one. So here your length is 5, width is 4, so your area is 5 times 4, which is 20. And then your answer should be unit squared, okay? If you don't have a unit, like for example, it could be like 20 inches square or squared inches, but since it doesn't have that, you just put unit squared. For number 2, I see is that a 7? Oh, it's a 7 and M. Okay. So your length is M, your width is 7, so your area is M times 7 or 7M. Okay. For 3, your length is going to be A and your width is 3. So your area is A times 3, which is 3A. For number 4, your length is X. And actually, in this case, your length and width are exactly the same. So this is a square. So we could just say S or the side is equal to X. So area of a square is S times S or X times X, which is X squared. It's not 2X, okay? There's a difference there. So then for number 5, it asks you write the area of each rectangle as a product of length and width and also as a sum of the area of each box. So the example here is the area of the product of this rectangle right here, right, is 5 times x plus 7. Wait, x plus 7. Oh, because, okay, so it's not this box. Just kidding. Sorry. So this 5 is your width. Your width is 5, right? Your length is going to be this plus this. So x plus 7, right? So your area is going to be 5 times x plus 7, right? Because it's going to be width times length. But then when you distribute this, right, you'll get 5x plus 35. You see that? Okay. So for number 6, okay, x is going to be your width. Your length is x plus 12. Area as a product. Your area is length times width, right? Your length is x plus 12. Width is x. So in this case, you're going to do the reverse distributive property, which is going to be x squared plus 12x. One of the biggest mistakes that kids will do, they put 2x plus 12x. Do you see that? And this is incorrect. It's x squared. X times x is x squared. So just so you know, oops, x squared is x times x. You see that? 2x is 2 times x. There's a difference. Do you see the difference? Okay, so don't make that mistake. For number 7, we are going to say A is the width. The length is A plus 8. So you're going to have A times A plus 8, which is A squared plus 8 squared. For number 8, rewrite each of the following as a sum using the distributive property. So 4x plus 7 is correct. A squared minus A. I see you put a 1A right here. 1 times A is just A, so you can get rid of that 1. For number 10, you will get 3m squared plus 6m. For number 11, you should get 4a squared minus 48. For number 12, it says fill in the missing. So the box here is 2 times x, which is 2a. So this essentially is like the area, right? This box is going to be, well, this side right here is still a 2, right? 6 times 2, which is 12, okay? So from there, you do 2 times x plus 6, which is the area. This is the width. This represents the length. Width is 2. Length is x plus 6 because it's the entire length. Do you see that? Okay. And then, of course, you multiply it by distributing that 2, and that's what you get. So let's take a look at number 13. Okay, 5x and 20. So 5 times what gives me 5x? X is correct. 5 times 4 is 20. So here I should have 5 times x plus 4, which is what you have, which is 5x plus 20. So good job. That looks good. Number 14, 6 times x is 6x. 6 times 8 is 48. So then to find the area of this, it's going to be 6, which is the width, times the length, which is x plus 8. 6x plus 48 is correct. Okay. This box, 10 times x is 10x. 10 times 3 is 30. 10 is the width. Your length is x plus 3. Your area is going to be the width times the length. So when you distribute it, 10x plus, this should be a x plus 3. Okay, perfect. So then 10x plus 30 is your answer. All right. Then we have the back side of this page. It says, are the area as a product and the area as a sum equivalent? How does the visual help you determine whether or not they are? So the area as a product and area as a sum equivalent. So area as a product just means area equals length times width, right? The area as a sum equivalent kind of breaks it down like this. So that way you have this side might be W, but this side might have to be like, this is A and this is B, A plus B, right? What's the difference? The only difference is that with sum equivalent, your area is width times length, A plus B, which means you have to do what with it? You distribute the W into A times W and B times W, right? So you have to use the distributive property, right? So first question, are the area of a product and the area of a sum equivalent? You got to answer that first. And are they equivalent? Yes. You could just say yes. And go back to the question. Look at the question. Yes, the area as a product is equivalent to the area as a sum. Okay, so you answer the first question. Then we want to answer the second question. What is the second question? How does the visual help you determine whether or not they are? You could say the visual breaks the rectangle into 2 pieces. And then from there, you could just say, find the area with what property? Property, okay? So there's your second question. All right, what do you need to know in order to write the area in both formula? What do you need to know? How do you find the area? Area equals what times what? Length and width. Notice that in the area as a sum, the length is broken into two pieces, right? Okay, factor the, or actually, let's see, any area, you could just write area equals L times W, right? Okay, number 16, it says factor, oops, try that again. Factor the following expression. So the way I kind of remember how to do this is that this one, it's kind of like opposite. Distributive property. Okay. So this is 4 times m plus 4 times 4. Do you remember greatest common factor? Here is 4 between 4m and 16, right? So then what do they have in common? They have in common 4, right? So you're going to take that 4 out and you're going to take this 4 out, okay? It's a plus. You put a plus sign in between them. What number did we just take out? The number 4. What number's left? M plus 4, right? If you were to go ahead and check your answer, you just need to do the reverse, which is the distributive property, which is 4m plus 16. And that is correct with what I had before, right? Okay. So let's go on to the next one for number 18. Greatest common factor between 5 and 35 is a 5, and they're both negative, okay? So you take the negative 5 out, x plus 7. Do you see that? That one's a little bit tricky because if you take it negative 5 out, that has to change to a positive because negative 5 times positive 7 is negative 35, right? You had to switch signs. So I'm going to put a little star here. Be careful of sign, okay? All right, so then let's take a look at number 17. Greatest common factor between 9x and 81, I would say is 9, right? So you take the 9 out, x minus 9. That's your answer, okay? Greatest common factor, 4x and 14 will be a 2. So 2 times 2x plus 7. So good job. Write a definition for each word. Distributive property. I don't think a sum that is equal to a sum. I don't think that's correct. So online, whoops, hello. This is really weird. Hold on a second. Let's see, where is that? So we went online to figure out what is the distributive property, and this is what was given to us. So let's minimize this. And we'll put it right over here. So it basically said that the distributive property in mathematics states that for all numbers a, b, and c, okay? A times parenthesis b plus c close parenthesis equals a times b plus a times c, right? So in words, this means that multiplying a number by the sum, so multiplying a number, that number is a, by the sum of two other numbers is the same as multiplying the number by each of the other number and is adding the results together. Do you see that? Okay, so reword that, all right? Factoring when a, what is that? When a what? Okay, well, when we did factoring, do you remember how we found the greatest common factor? And we took that number out, right? And we left the remaining numbers or letters in parentheses. So I like to think that factoring is kind of opposite of the distributive property. Okay, so here is the online explanation. Let me minimize this. So this one says, factoring in mathematics is the process of finding the factors that multiply together to give you a specific expression. For example, in the expression 2x squared plus 5x, factoring will involve finding the common factor. So greatest common factor of 2x squared and 5x is just x, right? That's what they share, right? They don't share any numbers, unfortunately. And so factoring involves finding the common factor of the term to simplify the expression, such as factoring out the x. So if I take the x out, what stays inside? 2x plus 5, okay? So rewrite your definition, maybe include an example in there. That will be nice, okay? And that concludes your homework assignment.